Hi and welcome to paper 2 of the Edexcel predicted paper for June 2016. I promised a few people last week that we wouldn't just stop at paper 1 but we'd do paper 2 as well. Now this one, unlike paper 1, is going to change after the paper 1 exam. The reason for that is obviously no one knows what's on the papers. That's the whole point of these things. But eventually we'll find out what's on paper 1. Now, if topics that I'm saying probably will be on paper 2 turn up in paper 1, which is absolutely more than likely, almost certain if you look at all of the questions, then what I'll do is take those out and replace them with the next sort of topics that are likely to come up. Because obviously over the 2 papers I can't do every single topic. I pick the ones that are the most likely to come up, so there's plenty of topics I can put in as a replacement for those after the paper 1 exam. It also means that when the paper 1 exam comes and we know what's on it, then the paper 2 prediction gets a lot more accurate, since there's certain topics that obviously they won't ask again. They only ask topics once. As before, we have PDFs for this, which I'm sure will come up in a caption on the screen now, and you can do this whole paper online on our website, and I'll do a video soon explaining how to use the website. I think it's pretty self-explanatory. Go to our homepage. I'm sure there's a link come up now. Go to our homepage, and on the front it says paper 2 prediction. And it just talks you through the rest. The good thing about that is it marks it yourself, marks it for you, so you know exactly how many marks you got per question. And I would say now this paper, the paper 2, has turned out some quite tricky questions. I think this is harder than paper 1. I think paper 1 didn't have as many harder questions on it. But that's sometimes the case with the actual Edexcel papers, is you'll get one that has all the nicer topics and one that has a little bit more complex topics. So I think that's everything. Let's get started. So as always, pause the video now and have a go at the question. Okay, let's get going. Let's make a start. So, Jenny wants to buy a laptop. So this is an exchange rate question. Laptop is sold in the UK and USA. The laptop costs, and I always like to try and highlight these. So that's a number I'll need, and it costs that in the UK. And the exchange rate is quite important as well. So those are the numbers in the question. So if it costs 2,880 in the USA, I'll need to convert that into British currency, because it wants how much cheaper it is in the USA than the UK. So how much cheaper is the laptop in the USA than the UK? So I'll need to subtract the amount in the USA from the 2,400 eventually. But let's work out what this is in pounds. So I'm going to be working this bit out and I'm going to be converting it. So I know to get from dollars to pounds, so to go this way, what do I do to 1.47 to make it 1? Well, sometimes you're timesing, sometimes you're dividing. In this instance, I'm going to divide by 1.47. That's how I get from one to the other. If it was converting from pounds to dollars, I would times by 1.47. So I need to get the 2880, and I need to divide it by 1.47. Okay, and let's get my calculator, and you can hear me typing in 2880 divided by 1.47, and it is 1959.18. Now I'm going to leave it there because I know I'm just going to give pence, but I don't need any more accuracy than that. And you should only ever round your numbers at the end, so if you want to keep the extra digits, that's not a bad thing. But I know I'll just be doing subtracting, so it won't make a difference to the answer. So this is how much the USA one costs. So USA in pounds. Okay, so it's £1,959.18, and I check here, so it says how much cheaper is the laptop? How much cheaper? Well, is that cheaper than the UK? Well, it is. If I'd got a number bigger than 2,400, then the question wouldn't make sense, and I'd be thinking, oh god, did I times and not divide? Okay, so check if it makes sense. Okay, so next thing is how much cheaper? Well, I need to do 2,400, which is the price in the UK, and I need to take away the 1959.18. Okay, and I'm going to put the answer in the box, so let's type that in. So 2,400 take away 1959.18, and I get 440 pounds and 82 pence. And you can see there, rounding it at that point didn't make a difference to the answer, but it's always probably best to only round your answer. Otherwise, if I had times that or divided it, it probably would have made more of a difference. Okay, so that's full marks, and you can see we've got 3 marks so far, so we're still on a U, but there's plenty of time to go. So let's move on to question 2. Pause the video now and have a go. Okay, this is probably a time where I'm regretting not putting my camera on and showing you this with the camera in my calculator in my hand. But most calculators have a brilliant fraction button, and I'm definitely press it for this one. So I press the fraction button, and I'm just typing in root 82. Then I press down to go to the denominator, 68.9 minus 50.8, and I just press equals. And it says write down all the figures of your calculator display. So all the figures I get, 0.5002975,214. Now, I set a task similar to this to a class I had a few years ago, and one of the students had a calculator that seemed to have an infinite amount of decimal places, and he tried to cram it all in. Now, with this question, they're looking for about, I don't know, maybe 6 decimal places, because some calculators don't go any further than that. The students sitting the exam might be having a non-scientific calculator, which I would not recommend, because it doesn't have the trigonometric functions on it, which you will need later. However, don't get obsessed with writing down, don't get obsessed with scrolling across and writing every single digit that the calculator can come up with. That is more than enough, and if you look at the mark schemes, that's got the marks every year. That's absolutely fine. Even if you cut off a few, but I'd recommend you write down a sensible amount. But if you're starting over here and going all the way along here, then it's not a sensible amount. Now it says write your answer in part A correct to 4 decimal places. So 4 decimal places, if I just get my highlighter, the 4th number is this one. Okay, so I'm going to finish on that 2. So we'll start 0.500, and now I've got to make a decision. Does that 2 stay as a 2 or does it go up to a 3? Well, the next number's a 9, so it's 5 or more, therefore that 2 goes into a 3, and that's 4 decimal places. Fantastic. Now some people say to me, well, hang on, I thought you said you don't count zeros and stuff for significant figures, decimal places. Decimal places you always just count after decimal point anyway, but if it was significant figures, then the 0 would be past the 5, and if the 5 is there, then you always count with decimal places and significant figures. Anyway, little point, let's move on. So question 3, pause the video now, have a go. Okay, so my ambition to have brilliant questions that change every time. I think one in every 500 one of these, the triangle goes off the page a little bit. So that triangle is supposed to stop on the next square over there. Let's add it on. Let's pretend that didn't happen. I might go in, if I've got time, and change the program a little bit. I think I've been optimistic to use all of the space. Anyway, so this is asking for a single transformation that maps shape A, which is this one, onto shape B. And be careful to get the order correct, because the answer will change depending on whether you're going from and to the shape. Now, has that flipped? No, so it's not rotation. Is it a mirror image? No, so it's not reflection. Has it grown bigger or smaller? No, so it's not enlargement. The only one left is translation. Translation. I forgot that this pen is rubbish towards the bottom. Anyway, so it's translation. if you can see that. So with translation, there's only going to be 2 marks. And actually, there's only 2 marks in this question. The second mark, so first mark for saying translation. The second mark is for saying how far up and how far right. Well, let's just count. So I pick a spot on both shapes. I always pick the top personally, but it doesn't matter. You can pick any of the points. And I count 1, 2. So it's 2 up. So 2 up. And I count how far right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12 right. 12 right. So it's 2 up and 12 right. And I normally double check because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Always pays to double check. And I always love marking students' work that has the actual jumps on it, because people who do the jumps never get it wrong. People who don't do the jumps and believe that they are above the jumps, well, you've seen now that even I do the jumps. Jumps are good. And then make sure that you count the spaces between the squares, not the lines. Some people would say 3 up because there's 3 lines there. That's absolutely rubbish. If you do the jumps, you'll always get it right. Anyway, lecture over. Question 4. Pause the video now and have a go. Okay, so you can see now that if we get this right, we're halfway into an E grade, which for some people that's excellent. For other people, that's just getting started. So, rule here is if 2 things have the same base, and this is what this A is called, the base is the big number, then and you're timesing them, then you add the powers. Okay, so it's 4 plus 7. You shouldn't need a calculator for, because 3 plus 7 is 10, so therefore 4 plus 7 is 11. Second rule here is if you've got an index or indice inside the bracket and outside the bracket, them 2 times. The reason for that, and I'm not going to write the whole of this out, but to the power of 6 means you times it by itself 6 times. Am I going to write the whole of this out? Oh, why not? That is my personality kicking in, that once I start something. So 1, 2, 3, 4, 5, 6. That's to the power of 6 means you times it by itself 6 times. And this rule here says if you times numbers of the same base, these all have base m, you add the powers. So 3 plus 3 plus 3 plus 3 plus 3 plus 3, we know is the same as 3 times 6, which is 18. So the rule here is just times those numbers together. Okay, that's the proof of the rule. Okay, and this last one, well, dividing sort of is the opposite of timesing. Therefore, when we're timesing, we're adding the powers. When we're dividing, we're taking the powers away. Now, be careful with this one, because there's actual numbers in there. Well, you know that 32 divided by 8, you know that that's going to be 4. So the first number is 4. And I just look at the numbers first. Okay, so I look just at the numbers and ignore everything else and just do the numbers first. Let's see if I can change colour. Okay. I don't know if it's work, but we'll see. So next I look at the R, and that doesn't work at all. Now that doesn't have a power on it, but we know that if it doesn't have a power, it's power 1. So it's R to the power of 1 divided by R to the power of 8. And don't forget, when you divide, you take away the powers. So 1 take away 8. So this one's quite unusual because it's going to be minus 7. Okay, because 1 take away 8 is negative 7. Okay, and the last one is the s to the power of 12 divided by s to the power of 6. And now this is nicer because 12 take away 6 is just going to be 6. I was going to write 2 there. I think I write 2 because I just know that students will do 12 divided by 6. So they get used to dividing because of the numbers, and then they just carry it through. So just be careful with that you take away the powers and don't divide them. Okie dokie, let's move on. Question 5. Pause the video now and have a go. Okay, so good old sequences. First thing, I just look at sequences and I have to do this. I have to show the difference. So 2 plus 6, I think it is. Looking at that. 8 plus, and always check a couple of them. So 8 plus 6, that's looking good. And 14 plus 6. Now they can put what's called quadratics. Most of you will know what that means. Where the difference isn't the same. It goes up by a different amount each time. So just be careful that it's always going up by the same amount. Next year, in 2017, those are going to turn up a lot more. Now some people do the next bit in multiple ways. We know if it goes up in 6, it's the 6 times table. Therefore, it's going to be 6n. But that doesn't look like any 6 times table I've ever seen. It's because all the numbers have been shifted, and to find out how much they've been shifted by, some people like going backwards 1, and to go backwards I would take away 6 because I'm going the other way, and 2 take away 6 is minus 4, so that makes sense. Minus 4 would be there, and that's what we look at. What I do is I look at this number here, okay, the 6 we found out, and I go, right, how do I get from 6 to the first number? How do I get from 6 to 2? And I take away 4. The next number in the 6 times table is 12. Let's see if that works. 12 take away 4 is 8, so it works. So it's 6n minus 4 is my nth term. Now, is 492 a term in the sequence? Now the actual exam will stop there and we'll just leave space for you. This being a self-marking thing, I can't work out an algorithm to mark your very random work. So I've said, right, okay, I'll tell you what, it's not, but write the term directly lower than it. So if you show that a term lower than it is not 6 away, then that proves it is. And this is one way to work it out. There's loads of different ways of working this out. Probably the most common is just get your nth term and get it equal to 492. Now I like doing lines down here, so let's get some lines going. I like doing lines down the page with this when I'm solving, and this is essentially what we're doing here. So I'm going to plus 4 both sides, so I'm going to add 4 both sides, so that would be 6n equals 496, and then I'm going to divide 6 both sides. Now if this was non-calculator I'd do some long division, but I've got a calculator, so 496 divided by 6. 496 divided by 6 is 82.6 recurring. Now I could stop there because that's proof. If 492 was in this sequence, that would be an integer. An integer is a whole number. So I'd write a statement here saying 82.6 is not an integer, therefore that's not in the sequence. The question I've said is what's the term directly beneath it? So the term directly beneath it will be the 82nd. So all I do now is do 6 times 82. Okay, I do that, and then take away 4. So that's what I need to do. So 6 times 82 on my calculator, take away 4, and it is 488. Okay, so 488. 488 would be the answer to my question on the website, but as I said, 82.6 recurring, therefore that's not a whole number, therefore that's not in the sequence, would be more than enough. But you can see that 488 plus 6 is not going to be 492, it's going to jump past it. It's going to be 494. Okie dokie, let's move on. Question 6, pause the video now and have a go. Okay, so we've got some weird context about cake and ribbon or whatever, but we can ignore that, or we can just take what we need to out of it. We've got a circle and we've got its diameter, so it's not its radius, it's full diameter. And let's have a look at what we need from the question. So ribbons are sold in 40 centimeter lengths. There's a conversion we'll probably need to use. And we've got the 7 inches there, which are the parts of this. So ribbon will go around the cake, therefore it would be helpful if we knew the distance around the cake. We know the diameter, distance across the cake, but we don't know what's around it. So we use our circumference equals pi d formula. Okay, the diameter, as we've said, is going to be 7. Okay, so if I type that into my calculator, times pi times 7, I get 21.99. Now I'm going to show the examiner that I've kept it in my calculator by just doing a few dashes, several dashes afterwards. That's saying to the examiner, no, I haven't rounded that, I just can't be bothered to write the entire number down every time. But I've kept it in my calculator, which I have done. But that's in inches. So I am a little bit, let's have a look. So 1 inch is 2.54. Now we did exchange rates earlier, but this time we're going from 1 inch to 2.54. So this time it's a times 2.54 to go from inches to centimeters. So I want to get that. So the circumference, so that's in inches. I could write inches. I don't normally like writing units until I get to the answer, but here, because I'm converting, I think it makes more sense. Times 2.54, and I'm going to convert it into centimeters. So I've kept it in my calculator and I'm timesing by 2.54. Okay, and that is 55.857, blah 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 blah. Now it says work out if one length of ribbon will be enough. Okay, so the exam question will stop there. Again, I can't mark it on the website unless I get an actual number from people. So by working out the length required in centimeters, so the length required is 55.8, and so when I round that to 1 decimal place, well, if I look at it again, 1 decimal place will be this 8. So it's going to be 55 point, and again I'm looking at the next number. Now the next number here is a 5, therefore that 8 will go up to 9. So 55.9. Now the last thing I do is I just check. I sit back and think, right, okay, does this make sense? Well, the ribbons are sold in 40 centimeter length. I'm expecting the answer to be around 40 if it's asking me to see if I've got enough. Very rarely on the exam do you find out that it needs a billion centimeter length or whatever. And 55.9 actually isn't that far away from 40. But obviously my answer to the question would be no, I don't have enough. I need another, 15.9. Okay. Let's move on, onwards and upwards, to question 7. So pause the video now and have a go. Okay, so some of the topics we're doing in paper 2 sort of have half come up in paper 1. But this is actually quite a different question. It's actually asking you to convert a standard form rather than divide with it. And this, oddly enough, comes up on the calculator and non-calculator, which is odd, because you can just literally type it into the calculator to work out question A. But we're not going to do that way because it could turn up in either paper. So to convert from standard form, I always just write down the number, leave loads of space, and -6 means this decimal point is going to jump 6 to the left. It's actually going to be a very small number, so I know that I'll need 0.0 blah blah blah. So I just jump it. So 1 jump, 2, 3, 4, 5, 6. So the decimal point is going to be here. I always start it off with a naught. So 0.0000063. So my answer is going to be 0.123456. Okay, I haven't left a space there deliberately. I've just missed a spot with a pen. But anyway, that space. Ignore that space. Okay, so next one. I always write the number out because it helps me. 0, 0, 0. Now, first question I ask is where's the decimal point? Well, if it's not shown, it's always at the end of the number. And I need to keep bouncing this decimal point until I get a number between 1 and 9.9. So if I leave it there, it's 85,000. Well, that's not between 1 and 9.999. No, still not. Still not. Still not. Ah, now it is. Fantastic. How many jumps did I do? Well, 1, 2, 3, 4, 5. So it was 5 jumps, and I was making a big number small, therefore it's going to be positive. If this number was 0.00, then that would be a negative. So I'm jumping from the right to the left. So I'm going left, therefore that's positive, whichever way you want to do it. And if we imagine the decimal point is there and not there, then it's going to be 8.53. And that's our answer. And you can see now we're on a D grade, if we got that right. And we're nearly halfway to a C grade, which is great. Into a D grade to a C grade. So I'm going to put both questions up. I'll tell you what, I'm going to leave that up. If you want to pause it now, you feel free. If the other one's too small, and I'm going to put the other one up as well. I'm going to do the answer with both of them up because I don't think I can read the data otherwise. So pause the video now and have a go. Okay, let's go through question A. Now, I think that graph's too small for me to go through, so I'm going to make it enlarge it, but I don't think I need the graph for B. So let's enlarge it, and then when I change it, the graph will disappear, unfortunately. Now, on the website, I've put this in because I haven't got round to being able to program. You're doing it yourself on the website, so you just put the coordinates in. The biggest thing about this question is understanding what a frequency polygon is. A polygon is when your parrot flies away. Boom, boom. Maybe not. If you get that joke, if you're laughing now, you need to see someone, I think. Frequency polygon, most important thing to realise is, unlike a cumulative frequency graph, you plot for a frequency polygon at the midpoints, not at the ends. And this is the confusing thing, is a cumulative frequency you plot at the ends, and the frequency polygon you plot in the middle. So if I fill out this coordinate thing, it might be easier. The frequencies, the heights, would just be as they are on the table, so that's pretty straightforward. But the midpoint of 0 and 10. Now, loads of ways of doing this. I think most of you will instantly know it's 5. But if it was more complicated numbers, what you can do is add these together and divide by 2. You're technically finding the mean of those two numbers. So 0 plus 10 divided by 2 is 5. 10 plus 20 is 30, divided by 2 is 15. But I think you can see the pattern here. And these are always going to be even for a frequency polygon. unlike a histogram where the midpoints might change. So let's try my best to plot this on here, although I'm not very good at doing this. I've for the histogram I've managed to get darker lines for the tens and fives, but I didn't get around to it on here. So forgive me if I'm off, but 1, 2, 3, 4, 5, and 9. So here, this is going to be arduous. Most of you will fast forward, I'm sure, at this point. Is it 11? So that's 10, so that's 11. Where are we? Does that say 50? Oh my goodness, all the way up here. Yeah, I think I missed that one. So that's 25. 35 is 24, so 20 is here, and 35. 20, so that's 20. 1, 2, 3, 4. Make sure when you're doing the exam you get these precise, but you're not using a dodgy pen. Bad workman always blames their tools. So 1, 2, 3, 4. Okay, so make sure you have them accurate. You'll find it a lot easier if you print this out with a PDF. You'll find it a lot easier to hit these points. Now that's not complete because we need to finish it off. The way we finish it off, if I get my black line tool on, is join them up with straight lines. Now I'll show you a mistake that examiners keep moaning about in a second. Okay, now that actually is full marks. You don't have to do any more. Some people join them up to 0. You don't have to do that for full marks. But some people join this one and this one up because they think a polygon has to be complete. Frequency polygon is just a description of the jagged edges of it. You don't have to do a polygon. In fact, you will lose a mark if you join this one and this one up to make it look like that. Okay, so don't do that. Just keep joining them up, go from left to right, never go backwards, so don't join this one up to this one, then this one, okay? Just join them up from left to right. I think most of you watching this video understand that, so we can move on. So my beautiful work will disappear now, because I couldn't find a way of programming it to shrink, and we'll move on to question B. So Sendy Town Centre have advertised the car boot sale with the following statement. So over a quarter of our stalls get 30 customers. So there's two things there, quarter over 30. Are they correct to say this? Show the proportion. Okay, so first of all we need to work out how many are over 30. So we look at these two here. So it's 24 plus 4. And I'll probably write that down for the examiner and show them, look, I know what I'm doing. So there's 28. And I need the total amount. So the total amount is all of these guys. So I'll probably use a calculator for this. I can do it without, but I've got a calculator. I might as well use it. So 9 plus 11 plus 50 plus 24 plus 4, 98. 98. So maybe total equals 98. So to work out proportion, you do 28 divided by 98. Okay, the bit we're looking at, which is the over 30, and over the total, and I get this decimal here. I'll do that, I'll show you that actually. 28 divided by 98, so I'm showing the examiner I know what I'm doing, and I get 0.2857. I don't need to go any further than that. A quarter is 0.25. So it says over a quarter of our stalls get over 30 customers, so I would probably say 0.2, and I'll go around this, 0.29. In fact, I'm going to round it one more time. So I'm going to do the 3 decimal places which it says it wants, and I know that that is greater than 0.25, which is a quarter. So my answer in the exam would be yes, because 0.28 is bigger than 0.25, so it's over a quarter, which is what they've said. But on the online, the limitations with online is I can't understand words, so I'm going to just put that number in there. And the numbers I ask for on the website are numbers that would get you the mark. Okay, so I've given you a little bit more guidance than perhaps the exam would. Okay, fantastic. Doing well so far. So we're almost at C. Let's see if the next question pushes us there. So question 9. Oh, so close. 2 marks away. So pause the video now and have a go. Okay, so I've been a bit controversial here in introducing colour into the exam, because the exams are printed with a black and white photocopier, so we never have any colour in them. But that doesn't stop me. I put colour in anyway, although not an awful lot, because I try and keep them looking consistent. So this is a best value. Again, you might not get all of this stuff. You might just be asked, right, work out the best value, and there's just loads of lines for you to do it. But again, online, I've tried to push you into a certain way. Now, so the exam would finish there, but I've said, well, okay, so I want you to write the price per tissue. Now, you could have done the amount of tissues per 1 penny, and that's absolutely justified, or you could get all of these to be the same amount of tissues, get all of these down to 5 tissues equals, and that's absolutely fine for the exam. But that would take me way too long to program a way of doing that. So I've just guided you and I've said, look, this is what I want, and the exam could do that. Okay, so I need to get the price per tissues. So I'm going to start off with the 24, and I've got 24 tissues, and that equals, and I'm going to work in pennies here now, and it's always easier working in pennies because you don't have the decimals as much. So I'm going to write tissues and price. Now I want the price per 1 tissue, and to get to 1 I divide by 24, because 24 divided by 1 is 1, and whatever I do to that side I've got to do to this side. So I'll get my handy calculator out. 515 divided by 24. And let's have a look. Rounded to 2 decimal places. So let's round this to 2 decimal places. So 21.46. And it says 58 on the calculator, but I've already done enough stuff on rounding. So that's the 24 pack. I could have used a straight line tool, but I didn't. I'm going to keep these headings going. So 20. So I'm going to do the 20 now, and that's 449 pennies. And I don't like putting units in my working out because you just end up getting letters everywhere, and especially when algebra's involved it gets confusing. So I'm going to divide that by 20, and so therefore I'm going to divide that by 20, and let's type that in. So 449 divided by 20. This is much nicer number to work with. So 22.45. Let's get my straight. Spent ages programming this with nice straight lines and everything, and I don't use them. It must be how people feel who buy their kids a ruler and they never use them. Maybe that's ringing home true for some of you. So 251. And I want to get that to 1. And the working out here is going to get you the marks. It's the working out that they're looking at. And if you set your work out like this, no one can possibly not give you full marks for it. It should be 15. Because it's just so clear. It's so easy to just look at and give you the marks. And the examiners want to give you the marks. So I'm going to do 251 divided by 15. And the answer is 16.73. Okay, so 24, let's bung these in here, 21.46, this is when my pen starts to worry, so 22.45, and this is 16.73. Now, don't always assume that the bigger boxes give you better value. Actually, a lot of Tesco, Asda, Sainsbury's and Morrison offers, the smaller one actually is cheaper, oddly enough. You wouldn't have thought. So in this instance, having a look at it, would you want to go in and shop and buy a box which is 21 pence a tissue, 22 pence a tissue, or 16 pence a tissue? I think it's a non-starter, because definitely 15 tissues are cheaper. So I'd write down 15 tissue box is cheapest. Now, some people love having a guess at these types of questions if they don't know it, which I recommend. I recommend you having a guess. But I will tell you now, you will not get a single mark for getting the right answer here, for guessing it with no working out. It's this stuff here and the correct answer that will get you the mark. You don't even get a mark for getting the right answer. You get nothing if you can't show how you got it. And you can see here the working out is really easily laid out. If I'm marking these, which I do, I mark my students and the national ones as well. When I'm marking these, I'm sitting back, and one like this is just so easy to give full marks to. I barely even register marking it. It's just full marks straight away. I know exactly what they've done and they've got the right answer. Okay, so remember that. Make it easy for the examiner. Examiners want to give you the marks, trust me on that. Let's move on. So question 10, and if we get this right, we're on a C grade already, which is fantastic. Pause the video now and have a go. Okay, so estimate the mean. Well, that's always going to mean one thing. It's going to mean exactly the same method every time. What we need to do is we need to times, let's get my thing back, times this number by this, get a column of what I call fx's, add them up, add this one up, and divide them the opposite way. However, I can't do 0 to 5 times 16. It doesn't make any sense. 0 to 5 is not a number. So we need to find a number that represents 0 to 5. The word estimate means that I don't know how many zeros, 1s, 2s, 3s and 4s and 5s there are. Okay, well I know there's no zeros in here, but I don't know how many 1, 2, 3 or 4 or 5 or 4.4s there are. So I have to represent that group with a number. And I'll need 2 extra columns for this, which is annoying because I've only done 1. Maybe I'll update that, who knows. So you need to have 2 extra columns. First column is what we call a midpoint. Okay, the midpoint is the halfway mark. It's not fair if I say this is 0 or 5 because that would be too small or too big. The midpoint 2.5 is fair because it's bang in the middle. And I do that going down. And don't forget, if you don't know how to find the midpoint, just add the 2 together and divide by 2. So you can see a pattern come in here, quite a straightforward pattern, good old patterns. I'm just adding 5 each time. Now I do an fx column. I don't know why I keep obsessing with this fx, but f stands for frequency, x stands for, well, it's technically ft because it's talking about t, but I could always call this x, I find it easier to remember. So fx just means these 2 times together. So I'm going to times all of these together. Okay, because there are 16 that we're saying are 2.5. Okay, well, they're not 2.5, they're anywhere between 0 and 5, but there's 16 of them, so I'm going to do, and I'll do this on my calculator, 16 times 2.5, which happens to be 40, that's a nice number. Then 6 times 7.5, which is 45. These are going out nicely actually. Look at these, eh? No decimals inside, so 12.5 times 16 is 200. Again, no decimals, this is great. 8 times 17.5. Wow, no decimals at all. 21 times 22.5. Ah, last one. Last one's a decimal, 472.5. Okay, now this represents the 0 to 5 group, the sum of them, like adding them all up, okay, assuming they're all 2.5. So we've added that group up, we've added the 5 to 10 group up, but we need to add all of the groups up. Remember, the mean is everything added together. The way of doing that is and I always like putting a little box here, I don't know why, just obsessed with it. And I say the sum, which is this sort of E character, sum of fx equals, totally not left enough room, but anyway, so 40 plus 45 plus 200 plus 140 plus 472.5. Okay, which is, I might have to do it over here, damn it, 897.5. Okay, so that all of them added up is 897.5. Fantastic. But the mean is then that I need to divide them by the amount of numbers. So looking at the frequency, I know there's 16 in that group, 6 in that group, 16 in that group, etc. So I want to work out how many there are all together. So I add these up. And I know some of you are screaming something at me now, and I know what that is. But we're going to walk through this, because sometimes what you're probably screaming at me for is not there. So I'm going to add these up. Plus 21, plus 21 is 67. Now, what some of you probably have noticed is it does say that in the question. I wrote the questions, I know it says it, but sometimes it doesn't say it. But if it does say it, make sure you recognise that. The amount of times I've marked one that thinks it adds up to 99 and the question says 100 people walk into a bank. It's like, read the question. Now, the mean is the total of them, the sum of them, divided by the amount of them. So these are the wrong way round, and they'll always be the wrong way round if you'd set out the table like I have done. So I draw this to help people. I just do this, and I call it X Factor. I don't know why, I think it was a popular TV show at the times that I came up with it. So X Factor, and the panelists are divided. Do you see what I did there? Fantastic. Okay, so 897, so let's type this in. 897.5 divided by 67 is 13.3955 blah blah blah. And it says to 2 decimal places, so that's going to be 13. I've got to be careful here, let's just check. So 2 decimal places, and this is a weird one, so I'll talk about this very briefly. That 9 is the last digit I want, but the next number along is a 5, so that 9 goes up by 1. Therefore, that 9 has to turn into a 10, which carries 1 on to the 3 to make that 4. If you think about it as a 39 turning into a 40, then it's a similar thing. 39 plus 1 is 40, therefore that 3 will turn into a 4, that 9 will turn into a 0. And that catches people out sometimes, so it's just one to watch. Okay, so if you get this right, if you've got every single one right so far, you are on a C grade, but you probably want more than that, so let's get going onwards. So, question 11, pause the video now and have a go. Okay, so where would we be without a good old inequality question? Probably much better off, who knows. Now, inequalities, let's have a look. So this question says x, which is an imaginary number. We don't know what it is, but we do know it's an integer. And the first thing to notice is that means whole number. Okay, so remember that integer just means a whole number. So 1, 2, 3, 4, 5, 6. 2.5 is not an integer. Okay, it says write down all the possible values of x. So, I need to know what this line here means, and actually it's normally parallel to that, but for the font I've used for the website, it's not parallel. So it would normally look like this, like parallel to that, rather than horizontal. Doesn't matter. That line there means equal to. That line there is not there. So that means x cannot be equal to minus 3. X is greater than minus 3. So let's think of integers greater than minus 3. Well, minus 2, minus 1, 0, 1. Hang on, I could be going on forever. So it says, well, hang on, x is less than or equal to 5. So that gives me room to stop. Now, do I include 5? Well, there's a line there saying, yes, do include 5. We want to include 5 in this. So I'll include 5 there. Fantastic. Right. Next question. There are two ways of doing this. I'll do the longer way first because people find it easier to remember. And then I'll go for a shortcut way. And I'm going to do my infamous lines down the page. Because they are fantastic and they are copyrighted Mr. Gilpin. So let's do my lines down the page, and we treat this as an equal sign with an important caveat. The caveat is if we divide or times by a negative to both sides, we need to flip the inequality sign. Okay, so you need to flip it. Let's see if there's a way of doing that. So if I have 3 is greater than 2, is this going to work? I think it is. 3 is greater than negative 2, and then I times both sides by negative 1. That would be minus 3 is greater than 2, which doesn't make any sense. So if all I've done there is times both sides by minus 1. So to counter that, you just need to switch the inequality if you times by negative 1, which we don't need to in this question, so I don't know why I've done it. If you watched paper 1 prediction, you'll know that I do my smiles and rainbows. That's also copyrighted, although I didn't come up with it. So 2 times 6x is 12x. It's not really copyrighted in case you're worried. 2 times negative 4 is negative 8. It's greater than 8. So I haven't actually done anything to solve it, but I've broken open the brackets, which is great. Next thing to do is plus 8 both sides, because I want to get that 8 out of the way. So 12x is greater than, and I'm in my head I know it's greater than, but I'm just doing the same as if it was equal. It's 16. Then I need to divide by 12 both sides. So x is greater than, and let's have a look. Type into my calculator, 16 divided by 12. I know what the answer is. 1 1/3, and it says round to 1 decimal place, so 1.3 would be fine. 1.3. X is greater than 1.3. Fantastic. Now, I said that there was a different method. This 2 is timesing the whole of this by 2. So what you could have done first is divided both sides by 2. And let's see if that works. So divide both sides by 2 and you get 6x minus 4 is greater than 4. Then add 4 both sides, you get 6x is greater than 8. And then divide both sides by 6 and you get 1.3. So that's a quicker way of doing it because you don't need to expand the brackets. But each to their own. Each to their own. Let's move on. So question 12, pause the video now and have a go. Okay, so you can see here we've now got a right angled triangle. So loads of things are flooding into my head on a site of a right angled triangle. I'm thinking, well, is it asking me for the area? That's the first thing. That would be a lower grade mark. No, it's not. Nothing about area. Is there an angle involved? Is it asking for an angle? Is it giving me an angle? No, it's not. So it's not going to be trigonometry. It's not going to be sine, cosine, tan, although that might come up later. Hint, hint. Maybe it will. So there's no angles involved. What's it asking me for? Well, it's asking me for this length here. And I'm going to call this x. It doesn't call it x itself, but I'm going to call it x just to help me out. You could call it capital AC, but I'm going to call it x. Why not? So we've got 3 lengths involved with 1 unknown, and that's screaming Pythagoras. Now, some people love using the Pythagoras formula. What is it? A squared plus b squared equals c squared. And that's great, and if you want to do that method, that's fine. We can run through it, not a problem. A and B are the ones that aren't the hypotenuse, and C is the one that is the hypotenuse. Therefore 25 squared plus 46 squared equals x, which I've called it, squared. And let's just do that on my calculator. So 25 squared plus 46 squared. Okay, so that's, and I'm going to just switch these around. So x squared equals 2741. And x, therefore, what I'm going to do is square root both sides. Okay, so I'm going to press square root, answer, and I get 52 point, what's it want? One decimal place, so 52.4. It's actually 3.5, but that 3 moves up. And that's my answer. Now, some, I don't know, more educated people appreciate the beauty of that. That's fine. If you're struggling with that, just remember there's 3 steps. Okay, so step 1 is you're squaring everything. You're squaring the things you've got. Okay, you're just going to blindly square both the sides that you've got. Step 2 is you're either going to add or subtract. Now, the important thing to realise is the hypotenuse must be the biggest. It must be the biggest. Therefore, if you're finding the hypotenuse, I'm going to add to try and get a number bigger than these two. But if you're given the hypotenuse, you want to take it away. So you want to take away that square. To do that square, take away one of these if you're given that. And then step 3 is just square root. Okay, so if you remember those 3 steps, even if you don't have a clue what I was on about with this, if you remember those 3 steps, you can at least get a few marks. Probably you'll get the right answer, because the only choice is here. So choice, that's your choice there, is whether you're adding or subtracting. But if you do the wrong thing, if you add accidentally, or subtract accidentally, then you do the check I'm going to talk about now. And this check, which I've just said before, is this number has to, because it's the hypotenuse, and the hypotenuse, you don't know, is the one opposite the right angle. The hypotenuse must be the biggest. Is that bigger than 46? Yes. Is that bigger than 25? Yes. Therefore, I know it's the correct answer. Okay? Unless I've made a mathematical error here, and there's probably going to be comments saying, actually, that's not a 46. Anyway, except for that. But if I got an answer of 32, or something lower, 16 for instance, then I'd look at that and go, oh, right, step 2 was wrong. I should have done the other one. Okay? So, there we are. That's Pythagoras for people who don't understand Pythagoras but can get the right answer. Let's move on. Question 13. And you can see we're almost at B grade, which is great. Pause the video now and have a go. Okay, so this is a question that's like a hidden algebra question. It is algebra, it's pure algebra. This is beautiful algebra in motion, and yet it doesn't present itself as algebra, which a lot of students have problems with. But the X sort of gives it away, and anything that says you don't know this, but he has 4 times as much, is going to be algebra based. So, first thing I need to do is just write all of this information in terms of algebra to help me out. So James is easy because he's got X. Sarah has got 4 times more than him. So if he has X, she's going to have 4 times more, which is 4X. And Robert, I don't know where I get these names from, 69 fewer than James. So that's James's there, and he's got 69 less. Fewer just means less. Okay, I'm sure most of you know that. So each merit point's worth 3 pence. All 3 have a total. So it's talking about totals. Now in algebra, you're going to have an algebraic way of describing something and an actual number that describes it. So our number that describes the total is 21.15. But that doesn't describe the total amount of merits. That describes the total amount of money. So let's deal with that first. So that's going to be 21.15 pence, because we're going to be dealing in pence, because each one's worth 3 pence, and it's easier dealing in pence than pounds rather than converting that to 0.03. And I need to work out how many merits that's worth. So I'm going to divide that by 3, because I know each merit is worth 3 pence. So I've got my handy calculator out, 2115 divided by 3, and it's 705. So I've now got what the total amount of merits is as a number, but I don't have what it is as algebra yet. So here I want to do total, and I want to add up in algebra how many merits they have. So James has x, Sarah has 4x, and Robert has x minus 69. So let's collect the like terms. X plus 4x plus x is 6x. And then that number I can't do anything with. So we've got it as algebra and we've got it as a number. And we know they are the same thing. Okay, they're both describing the same thing. Therefore, the next step is to get them equal to each other. And this is instantly worth a mark as soon as you do this. As soon as you write them equal to each other, the examiner goes, yep, this guy knows what they're on about. And I'm going to get my black lines out. So I've got one that automatically does it. Let's try this. 90-degree black lines. There we go. Look at that, hey? It's just beautiful programming. Anyway, and we're just solving like we do any equation. So first thing I'm going to do is add 69 to both sides. So 6x equals, and I just might as well use my calculator. I can do it in my head, but if the calculator's there, why not use it? So 774, and then we're going to divide by 6. So divide that by 6 and we get 129. So x equals 129. And with this type of question, they know it's complex, so they'll try and make sure that x is an integer, x is a whole number. Looking at this question, x can't not be a whole number. It has to be a whole number because it's talking about discrete things. You can't have 0.6 of a merit. It doesn't make any sense. So we know we've probably got it right if we get a whole number. If we got a decimal, then I'd be thinking, oh, let's check my working out. Okay, so you'd think you'd stop there, but it does say how many merit points each student has. So James is easy because James is x, so that's going to be 129. Sarah is quite easy as well because she's just 4 times as much. So 129 times 4 equals 516. Now Robert has 69 less than James, so I have to type in 129 again. Take away 69 is 60. Now you might think, right, okay, done, let's move on. It's worth, because you've got a calculator, just double checking this. Why not? So 129 plus 516 plus 60 is 705. Each one's worth 3 pence, so times that by 3 and divide that by 100 because that's in pence. And I get £21.15. Now I walk out of that exam knowing I've got that right. Okay, it can't be anything. I must have made a very complicated mistake if that all works and it gives me the correct answer. I can't have made a mistake. Anyway, so we're very close to a C grade. To a B grade. I don't know why I'm saying C grade. So question 14. If we get this right, we will be on a B grade, which would be great. So pause the video now and have a go. Okay, so a bit more algebra to get the brain stirring. And this is just a basic solve, but a bit more complicated numbers. And this can come up anywhere in the exam. Like it could be sort of as low as question 7, question 8, or it could be as high as 14. You really don't know where it's going to turn up. So I'm going to get my 90-degree black lines and just put them on. And these are just brilliant because to mark, these are so much easier to mark when students do this. So you can see everything straight away. And students have a tendency to drift off, and you know who you are. You drift off all over the page and then go up here somewhere. It's very difficult to work out where your working's going. Now we did something before when we had these where we divided both sides by 2. I can't really do that this time because there's an x on this side and there's 2 terms, so I'd need to halve both of those, and neither of those really like being halved. So I'm just going to expand the brackets here. And if you didn't watch paper 1, I put a little line there because it reminds me to times it. Okay, so 2x, and then we've got 2 times minus 2, which is going to be minus 4, equals x plus 3. And this works nicely because what I can do is take away x both sides. So it just leaves x minus 4 equals 3. And then plus 4 both sides. So that's x equals 7. So x equals 7. Nice and easy. And this one's not that difficult either. Oh no, I've picked the wrong one. Yeah, let's try and pick the right one. Nice, nice straight line. There we go. Okay, so first thing to realise with this is you cannot do anything with the numerators here whilst it's trapped in a fraction. This x and the minus 2 here were trapped in a bracket, so I got rid of the bracket. And this 4 and this minus y are trapped in a fraction. And to get rid of the fraction, whilst my computer does some background loading, to get rid of the fraction we need to understand what this line means. This line means divide. This is a divide, this is how we show divides. We don't use the divide sign anymore when you leave school. The divide sign's useless, we just put everything in fractions. Okay, so if that's whole of that divided by 2, first thing we're going to do is times both sides by 2 to get rid of the fraction. So that is 4 minus y, and that frees that up now we can do stuff with that, equals 1 times 2, which is 2. A couple of ways we can finish this off. The way I prefer is to add y to both sides. So you get 4 equals 2 plus y, and then take away the 2. So you get 2 equals y. What I could have done is taken away the 4, made that minus 2, and then times both sides by negative 1, but some people don't like that, so I didn't. If 2 equals y, therefore y equals 2. And with both of these, I can put them back in and see if they work. 7 take away 2 is 5, 2 times 5 is 10, 7 plus 3 is 10. That works. 4 take away 2 is 2, 2 divided by 2 is 1. Again, leaving the exam knowing we've got it right, and if we've got that right, we are now on a B grade. Let's keep going. Question 15, pause the video now and have a go. Okie dokie, so I've given you loads of time there, probably way too much. So we've got 3 dogs who eat different amount of dog food. The first one, Denver, gets 8 over 19 of the dog food, 8/19 of the dog food, and the rest share, and the Engel and Fido, not very inspired with dog names, share the rest. Now the important thing here is saying the rest. Okay, so we need to work out what the rest means. What is Fido's share of the dog food? Okay, so Denver is the first one we need to consider. is because he is getting that fraction regardless. So the first thing we need to work out is what's left. So I do 1 minus 8 over 19, and as you know, you just work out what you have to add to 8 to get to 19 to do that, which is 11. So there's 11/19 left up for grab between the other two. And it says they share it in a ratio of 5 to 3. So that's 5 parts to 3 parts. So how many parts are there together? And to work that out, you just add them. So there's 8 parts altogether. Okay. If there's 8 parts altogether, then I get this fraction here. Or you could write it as a decimal, but fraction's a bit easier because decimal will go on and on. With 19 as the denominator, certainly. And I want to work out what 1 part is worth. So I'm going to divide that by 8 because there's 8 parts, and I'm going to work out what 1 part is worth. So I do 11 over 19. You'll notice something when you do this, divided by 8. And it gives me 11 over 152. Okay. What I said, you might notice something. When you divide a fraction by an integer, you just times that 8 by the 19, and that will get you the answer. So it's 11 over 152. So that's 1 part. But it says what's Fido's share. It doesn't say what 1 part's worth. Well, Fido, because he comes second in the question, he's the second one in the ratio. He gets 3 lots of that. So we need to get the 11 over 152. And we need to times that by 3 because that's his share of it. So I'm going to times that by 3. Again, you'll notice something, and that's 33 over 152. So you could have done this all without a calculator by using fractions, but you'd have to use long multiplication for this. Okay, now it says it wants it as a percentage. Again, I can't have some people doing fractions, decimals, or percentages. On the website, I need to tell you what to do. So in your exam, you'd get the full marks for that because that is the answer. But to make that a percentage, I times that by 100. Okay, and press S to D on the calculator to get myself a decimal, and it says 21.7, and it goes on for a while. In fact, infinitely. I'm going to round that to the nearest percent. So that's going to be 20, not 21 because it's 0.7, so it's going to be 22. 22%. Fan-dabby-dozy. Right. And does that make sense? Well, Denver's getting roughly half, and Engel and Fido, well, Fido's getting less than half, 5 to 3, so he's getting less than half. Well, half is what, 50%, and Denver's getting just under half of it. And yeah, that looks right. It looks right. Fido's getting less than a quarter of the total share, so that makes sense. If I was getting an answer of 0.00039, I'd be thinking, hang on, Fido's getting a lot more than that. And you might ask the question of why they're getting different amounts. Well, you see, dogs have different dietary requirements depending on the size and their age. I have no idea, I haven't got dogs, but I'd imagine that that's true. Let's move on. Question 16. Pause the video now and have a go. Okie dokie. Right, one of the many issues with doing this live is I've actually got to do it without anything in advance, so I have no idea what the answer to this is, but it says it's between 5 and 6. Now, what some people like doing is trying 5 and 6 and seeing which one it's closer to. I just like picking one in the middle, and we'll see how that goes. So my x value I'm going to start with, because it says it's between 5 and 6, is 5.5. And I'm going to type that into my calculator. I'm just going to type 5.5, was it cubed, take away 5.5 squared, and I'm just going to write the answer in here. So 136.125. My comment will be too low, Okay, so how low is that? It's quite low, isn't it? So I might jump to 5.8. Let's go crazy here. So 5.8 cubed minus 5.8 squared. Type into my calculator, and it's 161.472. That's too high. So I've trapped it at least. There we are. There's some success. So if that's too high, I've got to go lower. And what's it closer to? Probably closer. I don't know. Let's try 5.6. So 5.6 cubed minus 5.6 squared. And so the one I'm trying is 5.6. And let's try that out. So that's 144.256, which is too low, but actually it's not far off. And now you might think, well, yeah, it's definitely going to be between 5.6 and 5.7. Why would I bother writing it? Well, the mark, or the second mark, and the first mark is for trying one between 5 and 6. But the second mark is for trapping it between two numbers. So I need to show the examiner that it's definitely trapped between those numbers to get the mark. So 5.7 squared. And that's 152.703, which is too high. So the examiner can see now that I've trapped it between 5.6 and 5.7. So it's somewhere between those two. Now, where it is between those two needs a little bit more work. Now, if I show a diagram here to help some of you guys out who have problems with this, I know that it's higher than 5.6 and lower than 5.7. If it's somewhere there, then because it's asking for one decimal place, and normally these days they do, then it will be 5.7. But if it's over here, then it would round to 5.6. So I need to know which one of those to pick. Now some people go, well, it's closer to 5.6. Look, 144, it's closer. Well, actually it's not too clear, and these aren't what we call linear relationships. So just because it looks closer doesn't mean it is closer. What would be great is if I had the answer to a number that's halfway in between, because I could see which side of this line it's on. And that number is going to be 5.65. That will show me whether it's this side or this side. So the last mark for this is trying the midpoint, the mid number. And let's try that now. So 5.65 cubed minus 5.65 squared. And that gives me the answer of 148.439 blah 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 blah, which is too high. Now if this one's too high and this one's too low, but this one here was too high, then we don't know exactly where the number is, but we know it's going to be somewhere along here. It's going to be on this side. Any number on this side, because this is midpoint, this is the decision between rounding to 5.7 and 5.6, any number on this side will definitely round to 5.6. So you've absolutely made sure that the answer will round to 5.6 to one decimal place. Okay, so there's an explanation about why the 5.65 is really important that you put in your working. Now, you could also put 5.64, but if it's higher than 5.64, then you haven't proved 100% that it would round to 5.7, for instance. Okay, so if you pick the midpoint, you just have to do it once, and then you've got a definitive answer. Okay, let's move on. Question 17, and we're almost at an A with this question correct. So pause the video now and have a go. Okay, so it almost looks like a compound interest question, but actually it's subtly not, because we're not repeating the same percentage each time. So he's got 1,300 in his bank, and he's going to get that interest for the first year and that interest for the second year. So the most important thing you realise is how to use multipliers, and some students hate them. I don't understand why, but you should really have a real good understanding of them. The way of working these two out as a multiplier is you always start off with 100. It's always going to be 100. That number doesn't change. And you're working out what you're doing. Well, here he's getting 3.7%, so we're going to add 3.7%, and that gives us 103.7%. That's not very useful to us with the calculator unless you know how to use your percentage button. So the next thing to do is make that what we call a multiplier. Now a multiplier is just a decimal. And we divide that by 100, so 1.037. Okay, so to do that we divide, I don't know why I did that, divide by 100. Oh, that's really messy. Let's try that again. So 103.7 divided by 100. Yeah, I think I've been doing this too long. I think I should go to sleep now. But anyway, let's keep going. Okay, so that's it as a multiplier. So the next one, 2.2. Do the same steps. So 100 plus 2.2 equals 102.2. And we need that as a multiplier. So 102.2 divided by 100 equals 1.022. So we've got the two multipliers, and let's just highlight them because they're really important, because they basically answer the question for us. So all we need to do is get the amount and times it by each of those multipliers. How easy is that? 1.037 and times by 1.022. Question that might be in your mind now is, hang on, wait a second, when you times by a decimal, a number goes smaller, and we know his amount should go up. I mean, it's a bank for it, for goodness sake. Okay, when the decimal is more than 1, it actually makes it go up. Second question, so that's why this works, because the decimal is greater than 1. Second question you might say is, well, do we have to add on what the interest is going to be? No, that's the beauty of the multiplier. The multiplier does all the work for you. So I'm literally typing in 1300 times 1.037 times 1.022. That's all I'm typing into my calculator, and it gets me the answer of 1377.7582. Now we know that 3.7 and 2.2, that's not a great amount of interest. It's not huge. But looking at this, it's got him £77. Well, is that reasonable? Yeah, I think that is about reasonable. Okay, 2 years of savings, his money has gone up by £77. It makes sense. Okay, so let's have a look at how to do the answer. So the pounds are going to be easy, but we always have to make sure we round to the nearest penny. So 75, but the next one is an 8, so it's going to be 76. So £1,377.76. That's the total amount of money. And just be careful it doesn't say how much has he made. So if it asks that, then the answer would just be £77.76. Okay, let's move on. And you can see we're almost at an A grade, so close if we get this right. So pause the video now and have a go. Okay, occasionally occasionally, it seems normal now for them not to just give you a Pythagoras question or a trigonometry question without some sort of problem attached to it, an unusual shape or whatever. And this is an example of them asking one of those two, which we'll explain in a second which one it is, by giving you a more complex example. But you do get quite a lot of marks attached to these types, and nationally people don't answer them very well, so if you get them right then you're definitely a step ahead of everyone else. So looking at this question, well, first thing that strikes me is it's made up of what I can see 3 right angled triangles there, and we'll explain what the other two, some of you might go, hang on, there's only one there. We'll explain where the other two are in a second. So I know it's going to be probably to do with either area, Pythagoras, or trigonometry, one of those three. Looking at the question doesn't ask anything about area. The area is not a part of it, so it's going to be Pythagoras or trigonometry. Straight away I can see that it's got an angle in it, and chances are if it's got an angle involved in it, it's going to be trigonometry, because Pythagoras is just talking about lengths. That doesn't mean you might not need Pythagoras, although for this question I doubt we do. So it's asking us for CE. When it says CE, it means the line between C and E, so it's the total length along here. Looking at this question, it doesn't look like it's going to be a nice easy one. It looks like we're going to have to work out one thing and then work out another. This right angled triangle here, it looks like if we knew a length and an angle on it, then we could work out what length CE is. So that's our target, is to work out a length and an angle. I've got right angled triangle sitting here. Now you might be thinking, well, how do you know that's right angled? It says this is a rectangle, so therefore that's a right angle there. Okay, so it won't always show you that it's a right angle if it explains the fact it's a rectangle or whatever in the question. And we've got a diagonal going across. So we've got a right angle triangle, we've got an angle, and we've got a length. What would be useful is if we had this length here, because that's a length on our right angle triangle, which we eventually will want. So I'm looking for, and let's just call it x for now. I'm looking for x. So first thing I write down is SOHCAHTOA, and I just remember this, but some people have acronyms, some of them ruder than others, of how to remember this, but this is one you absolutely must remember off by heart. And I need to label the sides, so this one's opposite the angle. Okay, angle's here, so this is the opposite. And this one's the hypotenuse because it's opposite the right angle. So this is our hypotenuse. Okay, so looking along here, am I using SO, am I using CAT, or am I using TOA? I'm using SO because, as you can see here, it uses the O and the H. So SO is a way of remembering that sine x, which we know is 61, so sine 61 equals opposite, which we know is 20, over the hypotenuse, which I've called x. Now, different ways of doing this. I know that if I've got a situation like this where I've got an unknown at the bottom, I can actually just swap these two things over. Okay, so I call it a prisoner swap. I have no idea why. Again, prison break was quite big when I came up with the term. So I swap these two over, and that absolutely works. So x equals 20 over sine 61. Okay, so let's type that in. 20 over sine 61. And I forgot to close the bracket. Be careful when you do sine, you close the bracket. And that gives me, now I'm going to write down quite a few numbers here because I don't know if I'll be able to keep it in my calculator, and it's asking for one decimal place, so I just need enough for that, and I'm just going to do dots. Okay, because I've not rounded that, I've just tried to write as many numbers as I can in case I need to clear my calculator. So I've got that number, so I've got what that is, and that is 22, this one here is 22.8 blah 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 blah. But I said I needed a length and an angle. Well, we don't have an angle. Well, we do. If this is a right angle here, then we can work out this one. And again, I mean, I could use my calculator, potentially. Why not? Let's use my calculator. I could store that one. So 90 take away 61. Okay, I know it sounds silly, and you might think, well, yeah, of course that's going to be 29. But on the stress of the exam, it's easy to make silly mistakes. Okay, and I've made that way too big, and that actually ends up looking like 290. So this is 29 degrees, and this is 22.867, blah, blah, blah. So we've got a right angle triangle, and we can use trigonometry now, because we've got a length and an angle. I've used x, so I'm just going to call this y, and this is going to be the whole length. It's not going to be a part, just one part. Okay, so the whole length. And what I can do is label them. So this is the opposite, but this time the x, on this angle is adjacent. So this is now adjacent, it's not a hypotenuse anymore. Okay, why have I said opposite? What numpty? This is the hypotenuse, because it's opposite the right angle. Okay, so opposite the right angle, this y is definitely hypotenuse, that's why I wrote opposite there. And adjacent to the angle. This one here would be the opposite, but we're not looking for it and we don't know it, so it's of no interest to us. Looking back at our SOHCAHTOA, let's have a look which one we're using. So we've got the adjacent and the hypotenuse, which is here, so it's going to be cos. So let's type it in, let's write it in. So cos, and the angle's now 29, equals the adjacent, which is that 28, whatever it is, 22.8, blah, 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 over y. And again, you can just swap these over like we did before, and that's absolutely fine. Okay, 22.8, blah, 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 over cos 29. Okay, so let's type that into my calculator. So 22.867081 divided by cos 29. And it says y equals 26.145 blah blah blah. So in here I just write 26.1 because it asks for one decimal place. And the last thing I do is just check that makes sense. Well, what's this distance here? So C to D. Well, it's going to be 20 because that's 20 and it's a rectangle. Opposite sides are equal in a rectangle. So if that's 20, does it make sense that that is 6.1? Well, yeah, it probably does actually. It doesn't look as long just looking at it. I know it's not drawn to scale, but just looking at it, that seems a reasonable distance. If I got the answer of 15, then I knew that would be wrong because I knew it was 20 plus some extra. So it's just simple ways that you can check your work to see if it's right. So we're 1 mark away from an A. I'm guessing the next one will push us over the threshold. So question 19, which it does, pause the video now and have a go. Okay, so this is stratified sampling question. It's the easiest thing ever, so I'm not really going to spend too long on it. We've got a whole load of people doing stuff, males and females. It has 95 people, and I've completely covered that up with that. This is why I introduced a highlighter to this. 95, and we're looking for a sample of 40. So we need to cut 95 down to 40. It wants to know how many females on the log flume we're going to ask. So at the moment that's 15. So that 15 is out of 95 and we want it out of 40. So the first thing I'm looking at is, let's have a think, different ways of doing this. I want that as a fraction of the total. So there are 15 females in the log flume and 95 in total. So that's the fraction, but I'm only asking 40 when I'm doing the sample. So I'm going to times that by 40. And then I just simply type it into the calculator. So 15 over 95 times 40. And that is a very long number, 6.31578 blah blah blah. Now you might be thinking, well, hang on, it's not saying round it to one decimal place, round it to two decimal places. Yeah, if you go into a serious business that's looking at sampling, and it's worth a lot of money if you're interested. There's an awful lot of money for marketing. What do you call it? Asking people questions. Market research. There we go. I got it in my head eventually. If you go in there and go, right, guys, we're going to have to ask 6.31578 people, they will laugh at you. You will leave that office straight away, and you won't get the job if it's an interview. I didn't say it was an interview, but if it was an interview. So we know that doesn't make sense. We need to round that. And the way of rounding it is obviously to the nearest person. Now, what you can do and should do sometimes is check all of these and check that they add up to the 40. So do this, what we've done here, for all of these, and check they add up to the 40. Oddly enough, the mark scheme now doesn't seem to be that worried about whether they add up to the actual sample size. They tend to give you the mark either way. What you'd do is, if you say if they added up to 39, which is more than likely, it could absolutely work out that way. So they add up to 39. You'd pick the one that's closest to rounding up, and 6.3 could be the closest one to round up. So you'd round that to 7, just so they added up to 40. Okay, but they don't seem that fussed with it anymore, so it might not be worth time looking into it. So if you got that right, you are on an A so far. Fantastic, as long as you got everything else correct. So let's move on. So question 20, pause the video now and have a go. Okie dokie, so let's have a look at this one. I'm pretty sure annual is spelled wrong, but anyway. So we've got sales, complicated sales question. So in 2015 their sales went down by 21%. So it's gone down, and their sales were that. So we know, so let's just do a diagram. So 2014 and 2015. And I do a diagram for amount, which is 9772, and percentage. So they've gone down by 21%. Okay. Few ways you can do this. What you can do is you can work it out as let's go for the easiest. The easiest is using multipliers, and I seem to be working for the multiplier company, if there was such a thing. I love multipliers. Multipliers are amazing. So in 2014 they had 100% of the money we're talking about. It's gone down by 21%. So let's get my calculator. I'm sure you can do this in your head. 100 take away 21. So it's currently at 79% of what it was. Okay. So I know that if I was going from 2014 to 2015, I would times by this multiplier, times by 0.79. But we want to go the other way. We want to start at the end and go backwards. And we know the inverse of times is divide. So you divide by 0.79. Let's see if that works. So let's type it in. 9772 divided by the multiplier, 0.79, if I type it in correctly. And it's telling me that the answer is 12369.62. Okay, and let's see if that makes sense. Well, they had 12,000, they've gone down by about just over a fifth, and it's now 9,000. Well, that makes sense. So 12,369 pounds 62 when I've rounded to the nearest penny. Okay, which it says to do there. In these questions, I think normally you'd get a whole number here. You won't get one that you need to round, but I don't know why I didn't make it a whole number, but anyway, I didn't. Move on. Okay, so the next one, they have a target to get their sales up to that. I haven't got a pound sign there, that's not very good. I need to write a note and change that. In 2016, work out the percentage increase they require. So there, again, I'll do a diagram, just for my sake. 2015 and 2016. Let's leave a bit more space. So 2015, we knew they were 9772, and 2016 they want to be 13 335. Okay, so simple equation you need for this. Percentage increase or change, it could be decrease, equals change over original, I'm just going to say orig, times 100. And it's that simple. So I'm going to the bottom here, so the pen might muck up. So I need to work out the change. Well, how much is it? How much will it change by? So 13335 take away 9772, and that gives me 3,563. So that's how much it's changed by. What's the original? Well, we know that it's currently at 9772. Okay, so the original is what it starts at before it changes. And be careful not to make that the final amount, because that's not going to be right. It won't give you the right answer. So let's do that. So 3,563 divided by 9772. And you might ask, well, why do we times by 100? Where's this 100 come from? This 100 just makes it a percent. Okay? And when I do that on the calculator, I get 36.46 blah blah blah. So rounded to the nearest percent, that's going to be 36%. Ooh, 36%. Let's check if that's realistic. Well, 36% is about a third, and yeah, it's gone up by about a third. A third of 9,000 is 3,000, and yeah, it's gone up by about 3,000 roughly. Okay, so roughly speaking, that looks realistic. If you got a percentage of 0.00 or 1,565,000, then clearly that's not right. Okay, so always just take a step back and look at your answer. Okay, so we're halfway through an A grade at the moment, which is great. Let's see how close we can get to an A star. Question 21, pause the video now and have a go. Okay, so there's two things you need to know for this. First thing is a way of describing this as ax squared plus bx plus c. Okay, that's the first thing. And I've totally missed out equals 0 on there. That's not good at all. It should equal 0, otherwise you can't solve it. Let's ignore that. Let's pretend it says equals 0. It probably will on the PDF when I update it. Anyway, so that's fine. And we need to find out what A, B and C are. So A is the number before the x squared, which is going to be 4. B is the number before the x, which is 5. And C, now this is the confusing one. It's the leftover number. It's the one that's not before an x or an x squared. But be careful, because this one's not a 6, it's a minus 6. If you think it's a 6, then you won't get the right answer. I said there are two things you need to know. The second one is the quadratic formula, which is given to you, but you should know off by heart. You should have had enough practice on this to just know it off by heart. So it's minus b plus minus, having said that, I'll probably get it wrong now that I'm doing it off by heart, but anyway, square root of b squared minus 4ac over 2a. Okay, and we're just going to bung the numbers in, and we know what they are, so we're just going to bung them in. Okay, I'm totally going to run out of room here, but minus b would be minus 5. I'm going to leave that plus minus because that just means we get two answers. Well, there's two answer boxes, so that's helpful. B squared, I know, is 25. Now, I'm not going to instantly put a minus here because I might not need it. So minus 4 times a, so 4 times a, and I can just do this on my calculator. So 4 times a, which is 4, times c, which is 6, is 96. But that's a negative there, that's a minus 4, and we're timesing by minus 6, so that's actually going to be a plus 96 over, that's a dodgy line, 2a, which is going to be 8. and then that equals minus 5 plus or minus the square root, and again doing my calculator, 25 plus 96, 121. Well, that's worked out well. You'll see why in a second if you didn't realise already. And I know that root 121 is 11, so minus 5 plus minus 11 over 8. Okay, so I then split this up into two because there's two different answers to this. First one I'm going to do is with a plus, so it's going to be minus 5 plus 11 over 8. So minus 5 plus 11 over 8 is 3/4 or 0.75. And then the second one I'm going to do is minus 5 minus 11 over 8. Let's type that in. So minus 5 minus 11 over 8 is -2, which we should know anyway. It's going to be minus 16 over 8. So my answers are actually quite nice. Normally you'd get a horrible decimal with this, but these are actually quite nice. They work out quite well. Excellent. Okay, so my forthcomings as a question writer ignored. Let's move on. Question 22, and we are very close to an A star if we get this right. So pause the video now and have a go. Okay, so bounds are basically the opposite of rounding, okay? When you've got a number, say 1.75, and you round it, one decimal place would be 1.8, but how do we know that that's going to round to 1.8? Well, this next number tells us. And bounds tell us where our upper and lower limits are. So if I just draw a line, which one's my line? This one. If I just draw a line here, and I want to know whether it's going to round to 1.7 or 1.8, like a number, an imaginary number. I know that if it's this side of the line, it would round to 1.7. If it's this side, it will round to 1.8. Our bound is going to be 1.75. That's where it decides which one it will round to. Okay, so it says write down the lower bound of x. So 1.8 there. Well, the lowest it can be, the absolute lowest, is going to be 1.75. So the lower bound of x is going to be 1.75. Okay. Now we've got quite a complicated question here. Okay. It says work out the upper bound for t and give your answer to 2 decimal places. So what I need to work out is how will I make t the biggest? Well, obviously x I want to be as big as it can be. So if I draw another line, let's do it over here. Fine. Okay. So if I draw another line, and I've got 1.8. Let's put it in the middle this time. Now I know the lower bound will be 1.75, but where's the upper bound going to be? Where will it start going to 1.9 over here somewhere? The upper bound. Now this is quite contentious. For me, it's 1.85. Okay, that's going to be the upper bound of 1.8. Now, some of you are screaming at me now, no, 1.85 would round to 1.9. Yes, you are right. And you might say to me, but it should be 1.849 recurring. Yes, you are right. But, if I show you simply, really quickly, what's a third? Third is 0.3 recurring. What's 2/3? 2/3 is 0.6 recurring, right? Makes sense. What's 3/3? Well, look, following the pattern, it's going to be 0.9 recurring, right? Because they're going up in threes or whatever. Okay, so 3/3, which we know is 1, is equal to 0.9 recurring. Therefore, 1.849 recurring is equal to 1.85. So although we know it's wrong to say 1.85, it's not any righter to say 1.849 recurring. And 1.85, first of all, will always give you the mark. Okay, there's no exam that will penalise you for not writing 1.849. recurring, because they know it's the same as 1.85. And secondly, it's a heck of a lot easier to work with 1.85. It's so much easier. Okay, so stick with it. Do it. Easy. Go for easy street. Okay, equals 1 over. Now, here's the complicated bit. We would assume that we want y as big as possible to find the upper bound for t, to find the biggest value of t. But when it's in a division, the number at the bottom we want to be as small as possible. Okay, we want that y to be tiny, so we're not dividing by a big number. When you divide something by a big number, it gets a lot smaller. That makes sense. That makes sense? I think that makes sense. So if it's 1/2, it's 0.5, but 1/4 is 0.25, which is less, it's smaller. Okay, so we want y to be as small as possible. So we need to take the lower bound of y. 2.4, so the next one along would be 2.3, therefore the lower bound will be 2.35. Okay, using sort of these examples, you could just write it out as 2.3, 2.4, 2.5, and work out the lowest it could be before it rounds to 2.3, which is 2.35. Okay, and I just simply type that into my calculator. So 1.85 plus 1 over 2.35, and that equals, what's it want to do? 2 decimal places. So 2.2, and it says 7.5, but again I'm going to round it to 8 because it's 2 decimal places. Fantastic. Okay, I think this next question will get us over the A star grade threshold, so let's get going. And I'm going to put both of them up for a little bit, so if you wanted to pause it now, feel free. So you can do both questions, and if you want to pause it now for the enlarged version, pause it now and have a go. Okay, I'm gonna do the smaller version just so we can get it all on one screen, because I think I'll need these for the later questions. So I apologise if it's too small, but we can cope. Now, histogram. The beauty of a histogram is the frequency is represented by the areas of these. I don't know why I said it like that, but anyway. So these are the frequencies here. Okay, and that's really important that we know that. So I didn't just stop it there, I just cleared the screen. So we know we need to work out the area of this to work out the frequency, and you might be saying to me, hang on, it tells you what the frequency is here. Always check it, and I'll explain why in a second. So let's check the area. 0.4 times 20, and that's 8, which it says it's 8 here. Now some people use this triangle, and that's absolutely not a problem using this triangle. The triangle is like a speed, distance, time triangle, but this time we've got frequency at the top, frequency density, which is this y-axis, and class width at the bottom. And this triangle's great, but unlike speed, distance, time, this is not an absolute relationship between these three things. The frequency density and the class width are proportional to the frequency. So if that frequency had been 16, we know we need to work out the area and then times it by 2. That's why you will always get one of these completed for you, so it can show you what it's timesing it by. In this case, it's timesing it by 1, so we don't need to worry about it. But be careful of that. I don't want you looking at this video, walking into the exam, and suddenly it's not working. Okay, so let's do the same with the next one. So the next one is 0.3 tall, and still 20 across, so that's going to be 6. Now, with histograms, the beauty of them is because the height is no longer the frequency, you can change the width of them, okay, because it's the area that's represented in the frequency. So this next one is not 20 across, it's only 10 across, so we're going to do 0.2 times 10, which I can't believe I just typed into the calculator, but it's going to be 10, okay, it's 10 across, so it's 0.2 times 10 this time. Next one's still 20, so it's going to be 1 times 20, and again, I can't believe I've just typed that into the calculator. And having a look at the next one, it's 30 across, so it's going to be 1 times 30. Okay, and be careful of that, because sometimes it's only the last one which is different, so you get in the habit of timesing everything by 20, and you suddenly get to the last one and it catches you out, so be careful. Now, next bit, it says work out the proportion of businesses in the sample that had a turnover greater than 80. So, I just dropped my calculator. So we want to work out, so let's get my line. We want to work out the area of everything past the line I've just drawn. So all of this, okay, because that's 80. So it's actually quite simple. It's 20 across and 1 up. So it's 1 times 20. What am I writing? 1 times 20. And we got lucky on this one. It's just going to be 20, isn't it? So it's right, your answer is decimal to 2 decimal places. Well, actually we don't need to because it's just 20. Let's just check that's right. Well, if that's 30, the whole thing, and that's 2/3 of it, then 2/3 of 30 is 20. So that works out nicely. Okay, so work out an estimate for the median turnover. So the median turnover. Now this is where it gets a lot more complicated. So for the median, I need to work out the total frequencies. So 8 plus 6 plus 2 plus 20 plus 30 is 66. So I can call that n. So n is 66. Okay. The median, therefore, so median is going to be that divided by 2. It's going to be the 33rd. Now some of you might say, oh, do you not need to add 1 to it? You don't if it's above 30, and some people say 30, some people say different amounts, but with histograms generally you don't. If the sample size is big enough, that's sort of an A-level topic which we don't need to go into, but normally histograms you don't add 1, you just halve it. So we're looking for the 33rd. We're looking which group it goes in. So the first 8 are in that one, so that's not going to be in that one. The next 6, that's 14 so far, are in 20 to 40, so that's not going to be in that one. The next 2 are in 40 to 50, so it's not going to be in that one. The next 20 are going to be in 50 to 70. Well, that brings us up to 36 so far, which is above the 33. So I'm going to write those both in. So we had 16 so far up to 50, and then 36 up to 70. This is where it sort of gets into a little bit of A-level. I always draw a line, okay, and I know this is my running total. So we've got 16, which we know is 50 or less, and we know it's 36, which is less than 70. Okay, and the median is 33, so the median's roughly here. Okay, we know that there are, I don't know what this is about, turnover. So the turnover for the bottom bit is 50, and the turnover for the top bit is 70. And we want to work out what the median turnover is. We're looking for this number here. Okay, so we're looking for this number here. So work it out as a proportion. So how far along is 33 from 16 to 36? And to do that, work out the distance between 33 and 16. So 33 take away 16, which is 17. Put it over the distance between 36 and 16. The distance between 36 and 16 is 20. Okay, so it's 17/20ths. And then I want to work out, well, okay, it's the same proportion between 50 and 70. So 50 times that by times that by the width, which is 20. And we know what this is going to be, is 17. So it's 17 along this line. Well, what's 17 plus 50 is going to be 67. 67. So the median is 67. Now, there are different ways of doing this. You can do this graphically by looking at the squares and finding the halfway point with the squares. There's loads of different ways of doing this. I would suggest, if you're not sure, grab yourself a revision guide, textbook or whatever. Or maybe I'll do a feature on this later on. Okay, but that's going to be the correct answer. Just check it makes sense. Well, 67 is I mean, the bulk of them are in this last group, so we'd assume that the median is going to be around here somewhere. So yeah, that seems to make sense. Right, so we're in A-star grade territory now. So let's move on to question 24. I'll pause the video now and you have a go. Okay, so we have triangles, but they're not right angles, and it doesn't look like we can make them right angles. So chances are, this late on in the paper, it's going to probably require either the sine rule or the cosine rule, or maybe both. So if I write the sine rule down, so sine rule is essentially A over sine big A equals B over sine big B. And you could carry that on, say C over sine C, but I've never seen the point because you're never going to need all three, he says. Right, the cosine rule is A squared plus B squared. Why have I written plus? Let's start that again. A squared equals B squared. I'm so used to doing Pythagoras, I think that's why. Plus C squared minus 2b c, what is it, cos, and then a, capital A. So you have to cos an angle. You can only use trigonometry on angles. Okay, so the little letters are lengths and the big letters are angles. Okay, you'll only ever use sine, cos and tan with an angle and not a length. And if we just draw and it has this in the front page of the exam, but people don't really take it in. If we have a triangle, the little a and the big A, the angle and the letter are always opposite, and same with B, big B and little b, and then big C and little c. Okay, they're always opposite. That's how we identify whether they're A, B or C. So I've written that down without even reading the question. Okay, so it's probably about time I read the question. The important bits, I mean, everything here is labelled in the question, so I don't necessarily need to take this in. Work out the length BC, that's probably the only part of the question that I need, so let's call that X. Now, like before, I can't go straight there. Looking at this triangle here, I've only got a length, and that's it, and an angle actually I've got. But with sine rule and cosine rule, I need more than that. Okay, if it was right angled, I could work it out with a length and an angle, but it's not right angled, so I can't use basic trigonometry on it. Looking at this, looking at the big triangle with X on it, yeah, I've got a length over here, and I've got one angle again, but I don't have another angle. Okay, so that's not going to help me out. What would really help me out looking at this is if I had this length here, because if I have this length and this length, then and this angle here, which I've got, then I can use the cosine rule. But I can't use the cosine rule on that yet because I don't know what y is. To find y, looking at this, I have an angle and a length opposite each other, and an angle and a length opposite each other, and only one of them is unknown. So it's going to be the sine rule first of all. Now this is already called big A, so I could call this little a, and I could call this big B, and I could call this little b. Okay, to help me out with this. Okay, so sine rule says, now I'm looking for a length, so it's helpful to have the length at the top. You can actually switch these around to put the angles at the top, and that's fine. So sine A over A equals sine B over B, and that would be fine. But I'm looking for the length, it's always useful to have it at the top. So y over sine 22 equals, and then the length 5 over sine 60. Okay, looking at this, I could times sine 22 both sides, so y equals this, then all of that times by sine 22, or I could just times the numerator. Okay, so I type that into my calculator. So 5 over sine 60, and be careful to have it set to degrees, times sine 22. Okay, because if your calculator is set to radians, then you will get a really dodgy answer. Okay, so I've got 2.162792175. Okay, because I know I'm going to be using this, and I'll probably want the whole number later on. I'll write the whole thing out. Okay, now I've got this length and I've got this length. Okay, so I've got my B and C, but I need my A. Okay, which A is always the angle between B and C. Looking at this, A is between B and C. Okay, and this is my B and this is my C. So let's call these C. So that's changed from an A to a C. And let's call this B. And I'm looking for this angle A, which was called B, but in this context now, talking about this triangle, this angle here is now A. So I need what this angle is. Well, angles on a straight line are 180. So 180 take away 60 is 120. I didn't need a calculator for that. And now I can use the cosine rule. So x is my a squared, or my x is my a, so it's going to be x squared. I'm just going to put these in straight away. Equals b, which is going to be 4 squared. B and c, it doesn't matter which way around you put them, as long as you're consistent. As long as you always put the same one. It doesn't actually matter. Okay, because we're just adding these together and then timesing them together. So that's going to be my 2.16 blah 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 squared. Then I'm going to take away 2 times 4 times 2.16 blah blah cos 120. Okay. Then all I'm going to do is put that into my calculator, which is not going to be easy, but anyway. So I'm going to square that plus 4 squared. Then I'm going to take away 2 times 4 times 2.162792175 times cos 120. Okay, and I get the answer of 29.32 blah blah blah. Now that's x squared equals that, so to work out what x is, I do need to square root that. So I need to do square root of 29.32 blah 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 blah. So what I'm going to do is I'm just going to press the square root button and answer. So it just square roots the number it was in there, and I get 5.42 when rounded. So my answer is 5.42. Okay, so there's 2 decimal places, so 5.42. It's actually 5.41561 blah blah blah. And depending on your accuracy earlier on, you might get a slightly different answer to that. With this question, they're normally quite lenient, and they understand the fact you probably rounded what y was or what BD was, and you might get a slightly different answer. And they sometimes say, well, any number sort of between 5.35 and 5.45 will give you the marks for. Okay, and that's quite lenient, which is quite nice of them. Maybe get them some Christmas presents next year or something. Anyway, let's move on. Okay, so I think this is one of the last questions. So pause the video now and have a go. Okay, so this looks quite complicated. I love my diagram. My diagram looks amazing. Anyway, that's not interesting to you anyway. What's interesting to you is how to answer it, so let's get going with that. First thing to realise, it's a cone, so we need to know the cone formula, so I'm just going to write that down. So it's a third pi r cubed, because it's a volume, pi r squared, because we're going to times by the height, so 3 dimensions, r squared times h. So that makes it a volume. Okay, that's the last time I do that from memory. Right, so frustum's made by removing the small cone from the larger cone. Work out the volume of the frustum. So we know we need to do two things. We need to work out the volume of the small cone and the volume of the big cone, and then take away the small cone from the big cone, okay? And that's the only way of working out the volume of the frustum. So I'm going to do the large cone first. Why not? And I'm going to show the examiner I'm going to do the large by writing the word large. So the volume is 1/3 times pi times, now the radius, if that's the diameter, 90, the radius is going to be half of that. So it's going to be 45. And 45 squared, sorry, times the height. Now the height is going to be 70, because it says 70 there. So it's 70. Let's type that into my calculator. So pi times 45 squared times 70 divided by 3. I press the equals there and then divide by 3, so I divide the whole thing by 3, and that's 148,440.2529. Okay, now the smaller one is a bit more complicated, so let's go through that. Now I can start it off, so volume equals 1/3 times pi, so I'm doing well so far. Now I don't know what the radius is. I have no idea what the radius is, okay, because it doesn't tell me. So what I need to work out is what the radius is. I don't know why I keep saying that. I need to work out what that distance there is, okay. If that cone is half the size of the big one, okay, and we're doing a linear scale factor here, okay, or similarity. If it's half the size, then the diameter, the width, will be half the width, okay? It makes sense. If it's half the size, it will be half the width, okay? So if it's 90 before, it's now going to be 45 across, which is half of that. And the radius is half of 45, which is going to be 22.5. So it's going to be 22.5 squared, and the height is 35. Okay, let's type that into the calculator now. So pi times 22.5 squared times 35 divided by 3 is 18555.03161. Now your argument might be, well hang on, if it's half the size, surely the volume will be half the volume, and it's not even close to half. I mean, look at it. It's 148,000 to 18,000. It looks tiny. Well, it's because volume scale factor, it works in a cubic way. Okay, so you've got to halve it, then you've got to halve it by, divide it by 8 basically, because it's 4 times 4 times 4, or 2 squared. Oh my god, it's 2 times 2 times 2, which is 2 cubed, which is 8, so therefore you divide it by 8. Anyway, you could have done it that way, and that would have absolutely worked, okay? But it's probably easier just working out both the volumes, because people muck up volume scale factor all the time. If I just give you a quick diagram, why not? So linear scale factor, if you times something by 2, if you double something, then everything doubles. With area, then if something is twice as big, you've got to times both the dimensions by 2. And with volume, if something is, let's just draw a cube, if something's twice as big, you've got to times all 3 of the dimensions by 2. Okay, so you end up doing 2 cubed, and which is why this is, instead of halved, it's divided by 8. Anyway, that's way too much detail, because that's not necessarily the way I do this question, but you would get full marks if you did. Now, to work out the volume of the frustum, so what do we call it? Frustum. Okay, and I'm just going to show the examiner that I know that it's large, take away small. and I want to do 148,440 blah blah, take away 18,555 blah blah blah. And I'm going to do that now. So that one, take away 18,555, and it is going to be 129885.2529, two decimal places, so 129885.25. Just about fit that in. Right, I think next question, the last one. So pause the video now and have a go. Okay, so we've got a right angle triangle, but we're not trying to find a length or an angle on the right hand side. And we've got a triangle on the left hand side. It's talking about areas, so whenever it's talking about areas and you've got a triangle like this one that's not a right angle, you're probably going to need this formula here. Now the formula is the area equals half AB sine C. And we've used AB and C before in the previous question, so I'm assuming you know what those are by now. The area of this one is slightly easier. Area equals half base times height. Okay, so let's work out this area first. So there's going to be half the base, which is 1, so times by 1 is nothing, times the height, which is x plus 5. Whenever you're doing this type of thing, always put these things in brackets. Okay, so get in a habit of doing that. So we've got the area for that. Now let's work out the area for this. So it's half, and let's name this. Well, this angle has to be C, because it's there's only one angle in the formula and this question, and so these can be A and B, and it doesn't matter which one you call A and which one you call B. So it's going to be x times x, so A and B are both x, so I could call that x squared sine 30. So let's type that into my calculator, sine 30, and I know that the answer is 0.5. So if that's a half and that's a half, half times a half is a quarter, so it's a quarter x squared. Now it says the areas are equal, therefore let's get them equal to each other. A quarter x squared equals half x plus 5. Now I've got a quarter and a half. To get rid of these fractions, I could times by 2, but that would still leave a half here, so I'm going to times both sides by 4. So I'm going to end up with just x squared equals, and half times 4 is 2, so 2x plus 5. And I'm going to just expand these out. Now I'm going to continue over here, give myself a bit of room. Okay, which you shouldn't have to do on your exam. You should have plenty of space. And I'm going to expand this, so 2x plus 10. Let's get this equal to 0, so 0 equals, I'm going to move these guys on the left hand side to keep that x squared positive, so I'm going to call it x squared, and I'm going to take away the 2x, take away the 10. It just makes things easier if that x squared is positive, for me anyway. Okay, so I'm going to continue this down here to use up all the available space. I need the quadratic formula, so it's going to be minus b plus minus square root of b squared minus 4ac over 2a. That should be x equals. Okay, so let's get this in. So minus b, well, b is minus 2, so it's going to be positive 2 plus or minus b squared, so it's going to be 4 minus 4ac. Now a is 1 and c is minus 10, so it's going to be 4 times 10, which is 40. So plus 40. Is that correct? Let's just check that. 4ac. Yeah, that seems to be good. Okay, over 2a, which is just 2 because a is 1. Okay, so 2 plus minus square root of 44 over 2. Now, a bit of simplifying of surds here, unless your calculator does it. I know 44 is 4 times 11. And 4 is a square number, so I could write that as 2 root 11. Okay. And then all three terms here I can divide by 2. So this could be 1. And I'm just going to call this a plus now, because I know that if it's root 11, it can actually be a negative as well. Okay, so it's absolutely fine to write 1 plus root 11, because everyone knows that square root of 11 could be negative as well. So, in the form a plus root b, a would be 1, and b would be 11. And that's it. Done. Finito. Us finished. Hurrah! Been a painful experience. Okay, so we have now covered both predictions for the Edexcel paper. The fun on the website doesn't stop there, obviously. There's loads of stuff I've got planned to do to help with revision. Some quick questions, some quick fire quizzes, etc, etc. I've said too much already. I'm going to try and put out some like past paper question videos. Try and put out some slightly different videos to talk about exam technique and news and how the predictions will change and what to look out for and what to revise, blah 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 blah, which will be exciting. I'm sure there's all sorts of little post-it notes coming up on the screen now of things I've done in the future and I've decided that you might want to know about. Thank you very much for all your very, very kind comments from video 1, from the prediction 1, and I hope that you've enjoyed and found useful the stuff that we've covered. If you haven't done so already, please visit the site. There's an awful lot of stuff on there that I've done already, and there's going to be loads more stuff on there. I'm adding new things every single week on there. The Twitter account is growing. I use the word growing because it masks the fact that it's not as big as I want it to be. I know it's only been there for a week, but it's going strong. I think 8 people have viewed it. Yay Twitter. I've got way more people who've seen my videos and subscribed on YouTube, so maybe you are all YouTube people and not Twitter people. I have no idea. I've only just found Twitter, so maybe that will grow with time. As you can hear, I'm getting very, very tired now, so I think it's, what time is it, midnight? Oh yeah, 20 to midnight, there we are. So it's probably time I go to sleep. Those are it for the predictions, apart from the fact that there will be another predicted paper 2 on the day, or I think it has to be a day and a half after paper 1. Basically, people are still taking the test for about a day and a half afterwards, and there's a bit of an embargo on the papers because internationally they take the test later than in the UK. So I'm not allowed to disclose any information about what's on the paper until a few days afterwards. But as soon as that embargo ends, that predicted paper 2 will be live on the site. I might even have a countdown. That sounds cool. If you've got any comments, questions, or anything else, please ask them. And please continue subscribing if you haven't already, and continue liking these videos so it inspires me to make more. That is more than enough of me talking. How long has it been? Over 2 hours now, so I should probably stop, which would be nice.